researchers update the distance at which a supernova would lead to a mass extinction on our Earth. How far would it have to be? Now, if you see the video before this one, we have had 4 supernova influences on our Earth in the past 40,000 years, the latest one being the Vela supernova 13,000 years ago, just about around the time of the Younger Dryas comet impact. So they found that from the tree ring analysis of carbon-14. But Lawrence, in 2016, researchers published slam dunk evidence based on iron-60 isotopes in ancient seabeds that supernova buffeted our Earth, one of them about 2.6 million years ago. University of Kansas researcher Adrian Mello, professor of physics and astronomy, supported those findings in Nature magazine with an associated letter titled Supernova in the Neighborhood. Mello has followed up since those findings with an examination of the effects of the supernova on Earth biology. A new research to appear in Astrophysical Journal, the KU researcher and colleagues argue the estimated distance of the supernova thought to have occurred roughly 2.6 million years ago should be cut in half. He says there's even more evidence of that supernova now. The timing estimates are still not exact, but the thing that changed the cause and to cause us to write this paper is the distance. We did this computation because other people did work that made a revised distance estimate, which cut this distance in half, but now our distance estimate is more like 150 light years. A supernova exploding at such a range probably would not touch off mass extinctions on Earth, Mello said. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. People estimated the kill zone for a supernova in a paper in 2003. They came up with about 25 light years from Earth. He said, now we think maybe it's a bit greater than that. They left some effects out or didn't have good numbers, so now we think it may be a bit larger, a larger distance. We don't know precisely, and of course it would not be a hard cutoff distance, it would be a gradual change. But we think something like more like 40 or 50 light years. So an event at 150 light years should have some effects here, but not set off a mass extinction, he said. In addition to its distance, interstellar conditions at the time of a supernova would influence its lethality to biology on our Earth. Cosmic rays like to travel along magnetic field lines, Mello said. They don't like to cut across magnetic field lines as they experience forces to stop them from doing that. If there is a magnetic field, we don't know its orientation, so it can either create a superhighway for cosmic ray or it could block them. The main interesting case did not assume the superhighway. It assumed that much of the magnetic field was blasted out by a series of supernovae, which made the local bubble, and we at the most recent supernova were inside. This is a weak, disordered magnetic field. The best analogy I can think of is more like off-road driving. In such a case, the authors think cosmic rays from the supernova at 150 light years would have penetrated to Earth's lower atmosphere. He said, this is much stronger thing. The cosmic rays from the supernova would be getting down into the lower atmosphere, having an effect on the troposphere. All kinds of elementary particles are penetrating from altitudes of 45 to 10 miles, and many muons get to the ground. The effect of the muons is greater. It's not overwhelming, but imagine every organism on Earth gets the equivalent of several CT scans per year. CT scans have some dangerous associations with them. Your doctor will not recommend a CT scan unless you really needed it. Mello said cancer and mutations would be the most obvious consequences for Earth's biology of the supernova cosmic rays. With his co-authors, B.C. Thomas of Washburn University, 2005 KU Physics doctorate graduate and recent winner of the A. Roy Myers Excellence in Research Award, M. Cashel-Reis of Institute of Physics Norway, D.V. Semicor Observatoire de Paris, Sorbonne, Paris in France, and National Research Nuclear University Moscow, A.C. Overholt, 2013 KU Physics doctorate graduate. Melot looked at the fossil record in Africa, the most geographically stable continent on Earth during the Pleistocene, when a supernova was likely to have occurred. He said there isn't a mass extinction, but there is kind of a lot of extinction going on at the time and species turnover. He said it's not quite severe enough to call it a mass extinction. There is some effect possibly connected to the supernova, he said. That's more difficult to say because there are many competing effects. Even in Africa, you have climate change, and you don't know if climate change is causing the effects you see or if a supernova has something to do with the climate change. In addition to cosmic rays, the team found a supernova would have caused blue light to shine in the sky at night for about a month. Can you imagine? That would have been beautiful, but deadly. So that's been shown to be a fairly bad thing for almost all living organisms, Willow said. It throws off sleep and messes up your melatonin production. I would never want a blue LED alarm clock in my bedroom. For example, blue LED streetlights have been shown to have bad effect in animals, causing behavioral changes, but this effect would only last a month or so, so I think you would never see evidence in the fossil record, he said. Atmospheric ionization would have been a more serious effect from a supernova, according to the KU researcher. Atmospheric ionization can help lightning get started, Melot said. When a cosmic ray comes down, it makes a path through the atmosphere where it knocks electrons out of atoms, and that makes a pathway for lightning to get started. We'd expect to see big increase in cloud-to-ground lightning. That would be good for some organisms and bad for others. Lightning is the #1 cause of wildfires other than humans, so we'd expect a whole lot more wildfires, and that could change the ecology of different regions, such as a loss of tree cover in Northeast Africa, which could even have something to do with human evolution. The Great Plains has recently been largely kept grass covered by a bunch of wildfires. A big increase in lightning would also mean a big increase in nitrate coming out of the rain, and that would act like fertilizer. So indeed, Melot said 2.6 million years ago, there was in Africa a loss of tree cover, an increase in grassland, possibly attributable to lightning-driven wildfires. We think it's possible that cosmic rays may have had something to do with that, he said. Melot added he's often asked by people if they should fear a supernova exploding close to our Earth today. And he said, I tell them they should worry about global warming and nuclear warfare, not this stuff. There's nothing close enough to cause this kind of event in the very near future. The closest potential supernova is Betelgeuse, about 600 light years away, according to Melot. It's much farther away than this one we've been talking about, he said. It's close enough to be spectacular in the sense that it would be bright and you'd see it in the daytime, but there'd be no harmful effects from that, he said. This is by Brendan M. Lynch, University of Kansas, on Bended Reality. Please leave your comments. Thank you for your support.